So good afternoon, everyone. We are going to start today's session. Although we were waiting for more number of participants, but I guess probably because of time, I think only 15 or 16 participants could join at 1:30. But again, since we have taken the consent yesterday and we have like announced in the morning also, so we are starting today's session. So we will start with the paired because yesterday we could do till independent sample t-test. So we'll start with the paired t-test. So as you can see, this is just opposite to the independent sample. So in independent sample, what we have learned that if we have counted one individual once, then we are not going to count the individual in the same category another time. But in case of a paired t-test, we are taking observation and that pair word, which you can see here, that paired t-test, that paired word comes with the paired observation, means two observation from the same individual. So we'll see in what type of research question we can use this paired sample t-test. So I'll be talking about the basic concepts first, then what are the various research questions for which we need this paired t-test, then assumptions and hypothesis, then commands and interpretation, and then I'll be summarizing the commands at the end. So let's say like if I want to measure any variable, which is a continuous variable on the same individual, let's say for example, systolic blood pressure. So if I take two seasons, like you know that there is a seasonal variation of blood pressure. So to just to document that or to show that there is a variation, I have measured the blood pressure in the summer and then in the winter. So I'm measuring the blood pressure twice on the same individual at two different time points. Or if I'm measuring the blood pressure under two different conditions, like before workout and after a workout, if I just want to see like what physiological changes workout brings on the blood pressure. Again, I have got one paired value or the two observations on single individual. Or it can be like on the single person, it can be two different sites, like blood pressure measurement in the right arm and in the left arm. So again, it's a paired value of observation, or it can be like using two different instruments. So if I'm using like two different instruments, which is automatic blood pressure machine and manual blood pressure machine, and if I want to say see the change in the blood pressure measured by these two, probably then I can again in all such type of research question, we can use the paired sample t-test. So in which type of study designs we can use? So whether we are measuring the same value on the two different time points. So the participants, so the study participants are the same and they are the tested at two different time points, or the participants are tested under two different conditions on the same dependent variable, like we have seen for this blood pressure. Two different type of blood pressure machine, the automatic blood pressure machine as well as the digital blood pressure machine. So like same participants are tested at two different time points. In this case, you can see if I take the mean intake of calorie, here it is written median, so mean intake of calorie, and then median intake of calories measured. So this will be in case of where you use the Wilcoxon, which is a non-parametric counterpart. But in case of this pair t-test, we are going to measure the mean. Or the same participants are tested for two interventions on the same dependent variable. Like I am measuring my outcome variable is the distance run on the treadmill, and my dependent variable are the two types of health drink. So health drink 1 and health drink 2. And then I measure the running distance over the treadmill. So here the dependent variable is a continuous variable and the independent variable is a two different time point. One group of people measured twice at two different time point or for two different conditions. And again, same like said, it can be two body parts of the same individual, Like if I'm using medicated lotion in one arm and non-medicated lotion in other arm, and I can just see like what is the diameter of redness. In case of if it is uniform both on right and left arm, if that redness is, then I can apply two different type of lotion in both the arm, and then I can see like what is the difference in the redness. So that is the case of a pair t-test. So what are the various research questions? So if I want to know whether there is any change in score in paired observation, so what are the different type of research questions? So whether there was a mean difference in BMI value before and after a 6 weeks exercise program, or comparison of pain score measured on VAS scale before and after surgery, or is there any difference in marks obtained in pre-university examination of MBBS students? Means that the two different examinations are the pre-university, or here we call it as a pre-professional and the professional examination of MBBS students. So in all these research questions, what have we observed? That there is a dependent variable which is continuous in nature, and we want to compare it at two different time points, the independent variable. So the appropriate statistical test is a paired t-test, and such type of research design is usually called a pre-post study. So it is also known as the paired t-test or a paired sample t-test. So there are some underlying assumptions, like we have seen in case of independent sample t-test, also the underlying assumptions. Here also there is an underlying assumption. So first assumption is that we test the dependent variable, which should be continuous in nature. And the independent variable consists of either two categories, related group or matched pair. And again, like the assumption of significant outlier in the difference between two related group should be tested, and it should be normally, and we say that the difference should be normally distributed, difference in the mean value, and that these options are there in case of a paired sample t-test in Jamovi itself. So what is null hypothesis? So null hypothesis states that the population mean difference between the paired value is equal to 0, whereas the alternate hypothesis states that the population mean difference between the paired value is not equal to 0. And like I said, if you are comparing median, then definitely you will see that you have to go, like if the normality assumption is not met, then you have to go with the it's a non-parametric counterpart, which is the Wilcoxon sign rank test. And that option is there in the same interface. So we'll see what are the different questions. So this is, I have to check the distribution of difference of the following parameters, pre and post stage. So this is the PHQ-4 score, anxiety score, and depression score. What I need to explain? Oh, that on day one also I have explained. We have explained to you that the PHQ, post PHQ, that we have created that dummy data, and this variable which we have shared. This was the pre score, and this was the post PHQ total. So this is one pre. In case of a PHQ total, this is, if you see the variable, it is the post. If you click on this, because in smaller this thing, it is only writing total, but this is the post. And this is, we have created this variable. We have not taken the response from all of you. Rather, we have created this variable for workshop purpose. So I have to test. So how I'll go? You click on the option of this analysis, go to t-test, click, and there is an option of paired sample t-test. So click on this paired sample t-test. Then you have to move the pair together. So like I have to use the PHQ pre and post. So I will click on this PHQ pre and then press the control and then PHQ score total post. And then I have to move these two together in this box. The other two, and you can move more than one pair here. But let's see about the assumptions. So assumptions, you have seen that it should be, if you check the QQ plot, you can see the QQ plot. So QQ plot seems to be normally, you can say like near normal. And then you can see about the other two scores also, like depression and the anxiety. So I'll move this anxiety and then anxiety total, this thing, press control, anxiety total score. Similarly, depression pre and depression post. So whatever comes first, the second value gets deducted from the first. So this doesn't seem to be very much normally distributed. And you can check these, we have checked these in the descriptives also. So they were not very much normally distributed. And then what you can do in this case, since we don't take the assumption of equality of variance. Why? Because it's not the two population. Rather, we are measuring the same people at two different time points or under two different conditions. That's why the equality of variance assumption is not here. And then you can click on the, that student is automatically clicked and you can see. So let's for first one, we take it as a, so if you see this, these all are significant. If you see the total score, and you can click on the mean difference. So if you click on the mean difference, and then you can click on the effect size, the confidence interval, the descriptives also. So this shows the pre-post descriptive. Means pre mean was 3.15, post was 3.98, anxiety pre was 1.56, post was 1.92. Similarly, depression pre was 1.59, post was 2. And if you see the difference, mean difference gives you this thing, these three columns. And the value is negative. Why the value is negative? Because we have taken the pre minus post. Because if the post is more, here I have shown that pre minus post is negative. That means post is more. Score is more after this 1 week or so. So it is high. That's why it is negative. But this change is significant. And you can see this is your effect size. You can see the value of effect size for each these. And we will comment on effect size. Why? Because you can see that it is significant. The p value is significant. That's why you have to comment on the effect size also. Effect size is again type of effect size is Cohen D. And value is like 0.24, 0.17 and 0.18. And then this is the descriptive. And that you have to like write as a interpretation. If you wish that like this PHQ should be moved, and if you want to put like non-parametric here, seeing the distribution, then you can click on this Wilcoxon rank. And like I said, you don't have to remember the names. Even if you don't remember what is the non-parametric counterpart of pair t-test, no need to worry, because in the same interface you can see a named test. So this means that this is a non-parametric. Always the such named tests are non-parametric, and you can go for this, and then again you can see the value of, here it gives you the value, the median also, but IQR it doesn't give. IQR again, like we said, you have to go to the descriptive and you have to take that IQR value from there. So if you see this anxiety score, this is again, this p-value is significant, but this statistics, which you can see here, that's a Wilcoxon statistics. And this is the, in this case, you can see it is the biserial correlation in case of a non-parametric. In case of a parametric, it was a Cohen-D. So that is the type of measurement of the effect size. Option is there in case of a pair t-test. So pair t-test, if the data is normally distributed and there is no significant outlier, then you can go with the student value. If not, if it is non-parametric, means not normally distributed, this QQ plot, then you have to use this Wilcoxon rank test. This was about the pair t-test. Now coming to the similar paired observation, since this is a continuous variable. If your variable of interest is categorical and then you are measuring the categories over 2 time point, then the choice of test is McNemar. So we'll learn that also McNemar. I was supposed to take that on day 2, but that could not be done. So again, McNemar, the only difference between McNemar and pair t-test is the outcome variable or the dependent variable. Dependent variable is continuous in case of a pair t-test, whereas it is categorical in case of this McNemar test. So McNemar test is, again, we'll see what are the basic concepts, what are the research questions for which we need this McNemar test, what are the assumptions and hypotheses, commands and interpretation, and the summary. So what is the characteristics of a McNemar test? Again, like we call it also as a chi-square McNemar. So it is a non-parametric test. And here we measure the significance of change in proportion of a pair data. And it is also, like I said, it is also known as the McNemar chi-square test because the test statistics has the chi-square distribution. So what are the various designs which are possible in case we want to apply this McNemar test? So any pre-post study design where you are measuring the changes over time or over intervention in a categorical variable, or pre-post study if there are changes in time without interventions. Like the same example, blood pressure, if you are measuring the change in mean systolic blood pressure, then it will be pair t-test. But if I categorize that and make it like hypertensive and non-hypertensive, and if I'm measuring the difference in proportion of hypertensives in the summer and winter, then I will go with the McNemar test. Or if there are differences between the conditions, like in a crossover trial, you see that we just change the arm, the set of people, they go to the, like they cross the intervention. The person who has got first intervention will now get the second intervention. So in that case also, if you are measuring any categorical variable, then it is it will be the McNemar test, which needs to be tested. I mean, that test needs to be applied. So like I said, if you classify the systolic blood pressure as hypertensive versus normotensive, and if you are measuring at 2 different time points, or if you are measuring under 2 different conditions, like before and after workout, similar as like we have seen in case of a paired sample, the only thing what we did is a like categorical variable instead of continuous. So Shweta is asking for McNemar. So McNemar is always pre-post, like for pair t-test. In case of, like, I'll show you one, there's the article where they have done like training. We take many type of training. We assess their knowledge pre-training. And then we assess their knowledge post-training also. So you can apply these 2 type of tests. If you just go by the total marks obtained pre and post, you can go with the paired sample t-test. If you are taking like proportion of people who have answered a particular question correctly before and after, then you can go with this thing, McNemar test. I think we have shared that article and I'll show that article to you. So study design is, yes, it can be intervention or it can be only like 2 different seasons, like I said. If I'm measuring, like my thesis was on seasonal variation of hypertension, where there was no intervention, like 2 different seasons were acting as a 2 different time point. So I measured the blood pressure in summer, and then again I measure the blood pressure in winter. And it is a normal physiological phenomena that the blood pressure rises in winter. So the proportion of hypertensive, so I applied both tests. Pair T tests when I have measured the mean blood pressure change from summer to winter, which showed that there was an 11 millimeter difference from summer to winter. But if I measure the proportion of hypertensives, so the proportion of hypertensives were less in summer and more in winter. So it is not necessary that there will always be an intervention. It can be under two different conditions, it can be under two different time points, or it can be with the intervention also. Okay, so it is not always necessary, Divya, that it will be a interventions. It will be an intervention. Is it okay to everyone? Or like physiologically, you can see the blood pressure measurement in right and left arm. And if I just want to see in physiology, we do such type of exercises. Like you measure the blood pressure in, leg and right leg, right arm, left arm, and you see the difference. So here you are not doing any intervention. But if you change like mean, if you like measure the mean, then you will do the paired sample t-test. If you are measuring proportion of the same variable, then you will apply McNemar. So chi-square and McNemar difference, yes, they are very much different. Study design is different. In chi-square, what was the assumption? There should be, that's why I call as the chi-square test of association or independent. There should be essential criteria is that it should be independent sample. Because in chi-square, if you have taken individual ones, you are not going to take the same individual. Their value should not be, we have learned that it should not be a paired value. They should not be related to each other. They should not be husband and wife. They should not be a twin brother or sister, or they should not be related to each other anyway. Because then the assumption of independent sample will be defined. Whereas here the study design is essentially the paired. You are measuring the same individual under two different conditions or time point, before, after any interventions, before, after any training. So these study subjects and the study design are entirely different in case of a McNemar as compared to the chi-square. And if you measure thrice what? Thrice, then you have to go with the repeated measure ANOVA. If you are measuring quantitative, if you are measuring like proportion, then there is a Cochrane Q, which is the like extension of McNemar at 3 different time points. Okay, is it okay? Shweta and I think Girish. Audio setting I need to change. Oh, that I have already done. Voice is not coming.
It's good. 75% mic. Mic is very sensitive.
Is my audio okay? That's fine, huh? Otherwise, in recording, it is always very less.
Voice is low, ma'am, now.
Yeah, that's what.
Earlier, now it is okay.
Okay. So yes, I was doing some changes probably, but that was not very good. So now it is okay. So yes, have you understood this? So I think somebody's writing VAS score is generally 1 to 10. I didn't get this question, Dr. Girish. Like, what do you want to say about this VAS score? Okay, I guess maybe if you can
Hello,
clarify.
madam. Yes, madam. Madam, I want to ask, like you told that scoring system, you can take the pair t-test. But my
Yes.
doubt is generally this Likert scale will be like likely, most probably like that it will be there. And the VAS score will be between 1 to 10. So generally what was my assumption that if the VAS score and this Likert scale, you have to use the non-parametric test.
No, 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 not at all. It is non-parametric always depends on distribution. If the responses, you have to see the responses. If you have to see non-parametric, you always check for the normality. And then there are objective and subjective way to test the normality. If your responses are varied, then definitely, like in your case, we have taken many variables, like, and you see even the age was non-parametric. No, I mean, it was not normally distributed. So it depends on the kind of responses which you get. We cannot say as a blanket that, Likert scale will always be kind of, non-normal, or VAS will always be non-normal. There can be chances, definitely, and there can be chances with the other variables also. Even if you take the other hemodynamic measurement, like we have always seen LDH and SGOT and all, they are very many times they are not. That depends on the sample, how you take the sample, and the your characteristics of the study subjects. So we cannot say that it will always be a non-normal data. You have to check. And yes, if they are non-normal, then you have to go with the the non-parametric type of test. Is it okay?
madam. Okay, madam. Yes. Thank you, madam.
Why they are said? Because yes, there is a wide range, like from 1 to 10 VAS score. But generally, when do we measure VAS score? You will see, like, generally it is measured like pre-post surgery, any surgical intervention, or generally here we see, and in anesthesia, they, it is a very commonly measured outcome where they, with the one anesthetic technique and the other anesthetic technique, they usually measure the pain perception of patients in one
Yes.
type of anesthesia versus the other type of anesthesia. So there, it may vary, it may not. Okay. Is it okay?
Yes, ma'am. Okay, madam. Okay.
Okay. So
Thank you, madam.
sometimes Divya is asking, we asked to score the pain on a VAS score. You ask means you want to say like 4, 5, 6, 7, something like that, Divya? Out of 10 score? Oh, yes, that's another way. Because I said that after any Likert scale item which has got 5 or more responses, then that is treated as a continuous variable. So yes, that's why there is a NRS scale also, numeric rating scale, for this pain score, where the person is asked to rate it on a scale of 1 to 10. There are many perception scale also, you will see, where the participants are asked to measure the response in a scale of 1 to 10. Especially if you go to the marketing sector, you will see that whenever you go to a shopping mall and they ask you to like give point on 10-point scale, again that is a numeric. In Zomato and in other this thing also, if you see, they always ask you like how much you are satisfied out of 10, how much score would you want to give. So that perception or satisfaction along with this pain also, many times, yes, we take it in a 10-point scale, and in that case we treat it as a continuous variable. Generally at that time it is no more a categorical variable or a ordinal variable. So any measurement scale where the level of measurement, even if it is ordinal, the levels are more than 5, we treat it as a continuous scale. So yes, it's perfectly okay if you are giving a score of pain on a VAS score. Is it okay? Okay. So in the same this thing, we will move ahead. So now I think you are clear on the chi-square and McNemar. So the essential difference is in the study design, how you are measuring the individual. So it is the same example. Again, we can measure whether the depression present or absent. Like in this case, we have taken the PHQ-4 response from you people. And like if I take now, and maybe if I take, because you see that there is a seasonal variation of depression also. You will see that many people, they feel depressed if there is a less of sunlight. So in summer, there's a very intense sunlight, and in winter there is a cloudy and the day is very dull, many times without sun. So if I measure the PHQ score and I have to define the season, like from which month or which day to which day I'm taking as a summer. So let's say if I take the summer from 15th May to 15th June, and I measured the PHQ score of, let's say, 200 people. Again, I have measured the PHQ-4 score in summer. I'm not doing any intervention. And on the basis of PHQ-4 score, like, you know that if the value is up till 2, we call it as normal. More than 2, we call it as a mild, moderate, and severe sort of depression. So if I categorize it, and if I measure it over 2 different seasons, the proportion, then it will be a McNemar. If I am measuring the value, means the change in score, total score is 12 for a person. So the total score, if I am measuring the change in score in summer versus winter, then it will be a paired sample t-test. Am I making myself clear to all of you regarding the McNemar and paired sample? It's just the nature of variable. The study design is same. So if you are measuring the categorical variable at 2 different time points, it will be McNemar. If you are measuring the continuous variable in terms of mean and median, it will be a paired sample t-test.
या continuous को categorical में compare करके
I didn't get.
continuous को categorical में convert करके convert करना चाहिए.
Okay, so Dr. Shamshad is again saying the same thing, that we are categorizing the continuous variable into a categorical, like we have just done. We have categorized the continuous to using the transformation option in the GEMOVI. And then we measure it at 2 different conditions, like with one drug or with more than one drug. And again, we can do it with any type of interventions also, like before and after counseling. So what are the various research questions for which we can use this? So if we want to know whether there is any change in proportional scores in paired observations, we can use it. Like any difference in the proportion of BMI. Again, for McNemar, you have to make binomial category, means 2 category of proportion. If there are more than 2, then again I said you have to go with the Cochrane Q test before and after a 6-week exercise program. Then comparison of proportion of pain status, and pain I have measured like moderate versus severe before and after surgery, or any difference in proportion of passing and pass and not passed in pre-university and university examination. So in all these example, what we have seen, that there is a dichotomous categorical variable in each research question, and we want to compare it before and after. So such study design is again a pre-post study design, and it is also known as the McNemar test of paired proportion because it's a paired value. So the underlying assumptions are that dependent variable should be measured in a dichotomous category. The independent variable is generally they are the 2 categories or related group or matched pair. And here generally we say that it should be a random sample from the population. So the null and alternate hypothesis is we say that the population proportion difference between the paired value is equal to 0. And alternate hypothesis states that the population proportion difference between the paired value is not equal to 0. So I'll show both these two, demonstrate both these 2 tests. So this is the question for, I think, paired t-test. I have shown you how to do that. For McNemar, I will see the question. So I can just see the proportion. I'll show here only. So if you see, for that I need to see the variable because we could not set up the question. So I have to see. So two values we have taken only for the PHQ. PHQ pre and post and anxiety pre and post. So let's see. Yes. So I think I have categorized this. What I did, I have transformed this to depressed and normal. So it is a 2 category PHQ using this. If you see my classification category, if I apply this edit, I have used this thing, that if the PHQ 4 score is less than equal to 2, they are normal. Otherwise, they are depressed, right? Like mild, moderate, severe, I have clubbed it together and I have put a category together as depressed. So this is my pre. And then if I see the other, which is my post. So, and here the option of that using the same transformation will come. So like this is your PHQ 4 score category and this was the PHQ, this thing new. So what I did, I have used the transformation formula in what I have used for pre-PHQ category. I have, like here, I have selected the same PHQ4 transform and I have applied it here and it will be applied here also. The same category. So I don't need to make now another category of like making more than equal, less than equal to 2 and more than 2. So I can use the same transformation rule which I have used in my this thing PHQ category pre, which was a new category which we had to make that. Why? Because initially it was having 4 levels. So 4 levels I cannot show you the McNemar. So what we have done, we have merged the mild, moderate and severe together in one category and normal as a one category. Am I making some sense to all of you what I want to say? Can someone confirm yes or no? Then I'll go ahead. Okay, Dr. Samay is writing yes. Dr. Philip has a question. If the variable undergone normalized before the test and after the test the variable is skewed, what statistical test? I did not get. Before the test means, okay, you want to say like before and after intervention. Like before interventions, it was normal and after intervention, it was skewed, right? That's what you want to say. Dr. Philip?
Yes, ma'am.
Okay, so
Yes, ma'am. Same.
okay, so that's why you check the difference between these two. What do you see in paired t-test? It's not the individual value at 2 different points. The normality which you have seen in the paired t-test, the normality is tested for difference. See, depression total score pre minus depression total score post. So this graph which you are seeing here, QQ plot, this is not for the absolute score. What it does, therefore, before JAMOV, when we used to take the session on SPSS, in SPSS, this option is not there. You have to create a new variable where what you do, you just compute a new variable by deducting the post score from the pre score or vice versa. Whatever is the highest you want to like deduct the lowest from it and then you plot a QQ plot. So automatically that is not there in SP. It was not there at that time, maybe 22 version. Maybe we don't know about the recent version of SPSS like 28, 29. Maybe it may be there. I'm not sure. So the QQ plot, which is plotted in case of a paired sample t-test, that is the QQ plot of the difference of the 2 score. So it does not matter whether it is normal or not normal before or after. Even both are not normal before and after. But if you deduct it, like after you take the change value or the difference value, and if that is normally distributed, you have to go for the paired sample t-test. If not, then you have to go for the Wilcoxon. Am I making myself clear to you?
Yes, ma'am. Thank you, ma'am. Yes, ma'am.
Okay. So, and have you understood this use of the transformation rule? If you have made one rule at one place, how you can use the same rule at another place. And all these cases where you are transforming the categories from a continuous variable, and if it is the same rule, like if you are classifying income or if you are classifying PHQ or anxiety, of course it will be the same rule. Why? Because that cutoff score will be same even if you are taking it at 2 different time points. So how I will go for the McNemar. So McNemar, as I said, that it uses a chi-square distribution. So I'll go to the analyze, the same option of frequency, and I'll use this option of McNemar test. It writes that it is a paired samples. You can see here it is writing paired samples contingency table. So I will put row and column. So in row, I'll put like first pre-1. So this is the category, new category having 2 levels. And then I can go with the post new category in the column. And then here what you have to see that you have to calculate the percentage. And that's why this is also known as the change in the marginal percentage. Why? Because in row, what have I moved? Here, there might be difficulty in, understanding this table because both column and row, both are showing the PHQ category. But you have to remember that, row is pre. So this, if I just want to see the depressed individual. So this is row. So I can say this is my marginal percentage. So I have to say that 61 people out of 92 total. Okay. So if I have to take out the percentage of this, so this row will be, this will be your depressed. So there are total depressed is 92. It's not 61. I'm sorry. So marginal percentage means you have to see the margins, this and this. Right. So initially 92 were depressed out of total 170. Okay. So what percentage I have to write? I am right. Can I have a pen? Sorry. So 92 out of 170. They were depressed pre. And after like some time, maybe after any intervention or even if it is at 2 different time points, the percentage of depressed. So now I will see this column 108. It has increased. So what I'll see? It has increased because this column is post. This is the column and this is post. So I'll take this 108 and 170. So if I take the percentage of this, so I will just show how you have to, because the percentage which comes here, that is not the percentage which it shows. So I'm opening a calculator and I'm calculating the percentage of depressed individual at time point 1. So it will be 92 divided by 170. So the percentage is 54%. Right. I'm just taking the whole number. And then after that, it is now 108. So 108 divided by 170. So it is 63.5%. So I will write that maybe in winter, if I'm taking it at 2 different time points, the depression increased to 63% from 54%. Right. So whatever percent you take here, if you take this 54, it doesn't give you like column or row percentages doesn't give you any this thing. So that's why there's no point in taking clicking on this column and row percentage. And that's why it is you calculate basically the marginal percentage. So marginal percentage, I'll once again repeat. This row is for the pre. So this is depressed. This whole is depressed. If I'm measuring the depressed individual, so this 92 is the depressed one, this 92. Okay. And after this whole is depressed. So I will take this 108. And denominator in both cases, I will use this 170. So number of cases increased from 92 to 108 from summer to winter. But again, if you see the value, then it is not significant because p value is 0.07 and chi-square is less than 3.84, which is 3.28. So that's how you can write the interpretation. Like there is a change in percentage, but which was statistically not significant. Have you understood how we calculate the marginal percentage in case of McNemar? And we don't have to like give the percentages here, click row and column. Rather, you have to calculate it by seeing the margins of the column and the row. Can someone write yes or no so that I don't know whether you've understood it or not, or should I repeat it? Okay, Dr. Sunil is writing yes. Philip is writing yes. Okay. So if it is yes, then we may go to the breakout room and we may practice these two, paired sample t-test, and you use the same example. So I think we have shared the example of paired sample t-test, but not the example of this PHQ. So for PHQ, you have to do the conversion.
Anxiety भी है उसमें.
Okay, so Dr.
Pre-post
Shamsha,
anxiety.
anxiety is also there, so you can use the anxiety also, like pre-post, because anxiety is again, I think it is having two levels.
Yes, no.
So if you see the data and if you see the anxiety. So anxiety is yes and no. So you can calculate like pre-post anxiety or pre-post depression is also two levels. So you can use this variable also, the categorical variable, to apply the McNemar test and calculate the marginal percentage and interpret. Is it okay? So Dr. Anand, will you please open the breakout room? Sharing rights.
Yes, ma'am.